this reading, we'll look at different specs for similar method behaviors, and we'll talk about the trade-offs between those different specs. In particular, we're going to look at three dimensions, three criteria we can use to compare specs. First, how deterministic the spec is, in the sense that does it define only a single possible output for every input, or does it allow the implementer the freedom to choose from a set of legal outputs for any given input? Second is how declarative it is. Does it talk about what the output should be, or does it say explicitly how the output should be computed? That also affects the implementer's freedom. And third, how strong it is. So does the spec have a set of legal implementations that could satisfy it? And is that set small, or is it large? Now, not all specs we might choose for a module are equally useful, and this reading will explore what makes some of those specifications better than others. Let's start by talking about determinism. So remember the two example implementations of find that we had in an earlier reading. We had this one that we're now calling find first, that searches from the beginning of the array and returns as soon as it finds the element. And then we had this other implementation that we're now going to call find last, that starts at the end of the array and goes backwards. And so it returns the last occurrence of that value, the index of the last occurrence. So these subscripts first and last are not actual Java syntax. We're just using them here to distinguish the two implementations for the sake of discussion. In the actual code, this method would just be called find, and you'd either have this one or that one as your implementation. Now here's one possible spec for find. We're going to call it find exactly one, and its precondition says that the value you're looking for must occur exactly once in the array. And its postcondition says it's going to return the index where that value occurs. Now this spec is deterministic. For every state that satisfies this precondition, the outcome is completely determined. There's only one occurrence of the value in the array, so there's only one index where that value could possibly occur. And there are no valid inputs, no inputs that satisfy this precondition for which the find exactly one method is going to return more than one valid output. It's deterministic. Now both find first and find last satisfy this spec. So if this is the specification on which the clients are relying when they call find, then these two implementations are equivalent and substitutable for one another. We could use either one as the implementation of this find method. Now here's a slightly different specification. We're going to call it find one or more at any index. And its postcondition, instead of saying the value occurs exactly once, it just says the value occurs at least once. It has to occur in the array, but we're not saying it's exactly once. And the postcondition still says that we're going to return some index I where that value occurs. This spec is not deterministic. There are some inputs when the val occurs more than once in the array for which the implementation has a choice about which index to return. This spec allows multiple valid outputs for the same input. Now we say that it's not deterministic, but we're going to avoid saying non-deterministic, because the usual sense of that word in computer science means that the code sometimes behaves one way and sometimes another, even if it's called in the same program with the same inputs. And this can happen when the code's behavior depends on a random number that it's generating, or when it depends on the timing of concurrent processes. But a spec which is not deterministic doesn't have to have a non-deterministic implementation. It can be satisfied by a fully deterministic implementation. In other words, an implementation that will always make the same choice when you give it a particular input. But the client can't bank on that. So we're going to avoid this confusion with the word non-deterministic by saying that specs that are not deterministic are underdetermined. Now this underdetermined find spec, find one or more any index, is again satisfied by both find first and find last. Each one resolves that undeterminedness in its own fully deterministic way. But the point is that a client of find one or more any index can't rely on which implementation they're actually getting. They can't rely on which index I they will actually get if val appears more than once. Maybe the first one, maybe the last one, maybe one in the middle. Now, this spec could also be satisfied by a non-deterministic implementation, one that, say, tosses the coin to decide whether to start searching the beginning or the end of the array. But in almost all cases we're going to encounter, this undetermined specs is actually a choice that's made by the implementer at implementation time. So an underdetermined spec is typically implemented by a fully deterministic implementation.